Hi, welcome. My name's Andrew and this is the first video on the Getting into Game Dev channel. So bear with the awkwardness. I don't even think anyone's going to watch this, but I'm making these videos to more or less document, on a weekly basis my practice with coding. For these first few videos it'll be fairly frequent because I've got a lot of things to go through, but then after that point the aim will be to go to maybe a weekly update schedule. So where I am at the moment, I've been kind of seriously practicing this for 3 months, or serious hobbyist. And this is one of the first things that I made just as a quick little demo. So this is using Python and PyOpenGL. I just wanted to make a little maze board. You tilt it around and this marble moves. So I'll go and run it. And there it is. We've got a board, the marble moves around. And it has collisions and bounces and things, and great. Perfect. Now just note here the frame rate is 60 frames per second. I just set that artificially because otherwise it just wouldn't work so well. So if we let the frame update with no capped frame rate, then we can get it pretty fast. It was about 500 before. Just, OBS kind of takes up some of the CPU. 500, okay, cool. But it's not so much fun. And look, there are ways to get around that, but this is just an early project that I started. So, in terms of where I am at the moment, still kind of a noob, but learning OpenGL and using it through Python, and it seems to work fine. Gradually I'm looking to shift into C++ and OpenGL, SDL, whatever, GLFW, whatever is more convenient. Probably thinking SDL at the moment because Pygame is a wrapper around SDL, so there's not much extra learning involved there. But in terms of these videos, I figured we would start with really basic, just Python, Pygame, no OpenGL or anything, just to practice, some of the concepts behind 3D games, and then to gradually transition into OpenGL stuff. Okay. So I won't be running through this, but let's get started. So I'll just close this and open up. There, we're back. Okay, so I've just opened up a really basic Pygame project, and the purpose of this project will be to demonstrate some of the concepts that will be used later on. All right, so when I was younger and I thought about making 3D games, I thought, how do they do it? It turns out it's all about transformations, so I'll just minimize myself a little bit here. Okay, so you don't have everything on the screen to start with. You basically, or in a simple sense, you make like a good top-down game, and then you apply transformations to the data that you're storing in your top-down game to transform it and make it look 3D. So what I've got is I've got a set of walls, which I'm just representing with lines, and this dot represents the player, and the player can spin around and walk. We can see in the set of world coordinates, the player is not the center of the world, but this middle set, view coordinates, is basically the world according to the player. It's not spinning, but for example, we can see as we move towards the blue wall, that is coming up to the player, and so the idea is the player stays as a fixed kind of center, of the world, and the world kind of moves around the player. And as we build this up, we'll be looking at more complicated things, but I just wanted to take this section to dive into Pygame, because we'll have to kind of understand that first. So, great. Let's just run through the code. So we can see here, we've got a surface, which is the whole window here. It's called screen. But then we've got a model surface, a view surface, and a projection surface. So the model surface is here. It's just a set of, it's a texture basically, and as I draw these lines, they get blitted to the texture, and that displays here. And then this model surface is drawn within the screen at a certain position, and you know, same sort of thing. So if we just kind of open this up, probably the best place to look for specifications of these things is if you go to if you go to pygame.org, look at the documentation. They have some tutorials here which are pretty useful to start with, but then, you know, beyond a certain point, you look at a few tutorials online and then you do it. Okay, so this is my you do it version. Okay, so what do we have here? We have a bunch of colors, and these colors are defined in RGB format going from 0 to 255, so this all looks okay. Okay, so this bit Pygame display set mode, it creates a window and also returns a reference to the window if I wanted to do operations on it. Pygame time clock gets a reference to a timer object, and the use of that is during the game loop. At the end of each loop, we want to call this tick function, and if I put a number in here, that's the frame rate that I want the thing to run at. Otherwise it'll just run at its own rate. So as an example, let's take that out just like I did on the maze board thing and run this, and yeah, we can see it's running pretty fast, but similarly to the maze board, it's not doing frame independent movement, so that gets a bit of a hassle. Okay, fine. So, okay, so what I did is I had these things called Sprite Groups, and those can be useful for if you're doing automatic collision checking. I had an idea that I was going to try automatic collision checking with Sprite Groups, but it just didn't work. But that's fine, you can still, you know, code doesn't have to be optimal to work. Okay, so then what have I done? I've created a player object. I've got these wall objects. Now these tuples here are the left and right positions of the wall. If you view it top down, you know, x equals 10, y equals 10, stretching off to x equals 290, y equals 10. And these are the colors as I defined it up here. Okay, so let's have a look at the actual stuff. So this is all kind of, yeah, not too bad. So when we create the player object, because I'm inheriting from Pygame sprite.sprite, that class there, I have to call the initializer on that class, and that'll set it up and give it sprite behavior. In other words, lets it update and draw just as a normal sprite would. If you check out Pygame documentation, talking about sprite classes, but This Pygame documentation, as far as sprites, doesn't really do it justice. I would recommend this website, kidscancode.org, if you can get over, you know, you're probably not a kid, I'm not a kid, but we can still look at Kids Can Code. Probably this tutorial here, Shoot 'em Up, is really good for explaining how to use sprites, how to set up sprite groups, do collisions and that sort of thing. Yeah, so check that out. I would highly recommend that. Okay. So the really important stuff is the transformation stack. So if we look at the game loop, we start off with this variable running equals true, okay? And then we go while running. So this loop will execute forever until we look at events. So this Pygame event.get puts out a whole kind of array of events, and this for event in will loop through all of that, and there we have it. So if we get a quit event, now a quit event happens when you click on the X. Then set the variable running to false, in other words, stop that loop. So game objects is a sprite group, and the thing with sprite groups is you can just go gameObjects.update and it automatically loops through every element in the group and calls the update function on it. And this would work pretty much analogously to if you had like an empty list, and then every time you created an object you appended it to the list, you would have a whole list of objects, and you'd say like for object in game objects update. Okay. We call update. Now, how does update work? Well, if we look at update, for the player, we'll take inputs and move the player around according to the inputs. But then, this is a really important thing, call the model to world transform and then the world to view transform. So in OpenGL, there's a stack of transformations that are normally applied to objects. It's called, model transformation first, then view transformation, then projection transformation. But we can think about it in terms of, a model transformation will put your object from model coordinates. If you imagine this little player circle is kind of centered around the origin or whatever, spits it into world coordinates. So the model transformation puts you from model into world. Then the view transformation puts you from world into view, where the player is the center of the world. And then projection transformation will put you from view coordinates into projection, which is how it looks in 3D. Cool. So we're actually, if we kind of trace this, first we call model to world, and what model to world does for the player is just rotate it according to its direction, okay, and then set the center of that image to the position of the player. So it turns out for this player object, if I didn't let's try this. So we don't rotate it and we don't translate it at all. And that fails because need to do that. Oh, interesting. Okay, so maybe we do need to set it to the center of the world. Okay, so a little confusing because it's hard to That's just, yeah. Okay, so how are we going for time? I was going to make this a quick video. It should be a quick video. I shouldn't be taking this long to explain stuff. Alright, so what have we done? So this is going to just run this. These transformations, model to world, are going to place the player in the center of the, not the center, place the player at their position within the world coordinates. But then, okay, world to view, well, I decided that I wanted to set the player up so they're always facing upwards, because I guess that makes some of the transformations a little easier to visualize. I didn't have to. But then what am I doing? I am rotating the player so it's facing 90 degrees, in other words, straight up, and I'm translating the player directly to the center of that screen. Each of these surfaces are 300 by 300, which is why 150, 150 is the center of that screen. Then I'm blitting, which is just drawing the player into that view surface. Great. So that all makes sense, I guess. If we go, just quickly checking. Okay, so look at each of the wall objects. So the walls are already in world coordinates. That's fine. We don't have to do anything there, but we do have to translate them to the view position. So what are we doing? We get the, what we want to do is we want to go from the camera to a position on the wall. And the way you do that, if you imagine changing two positions into a direction, it's your end direction minus your start direction. So we take our direction, and this will basically take the negative of the camera's direction. So when we add those together, we've got our direction minus the camera's direction. And I made this function here called translate, which basically adds these two positions together. So we'll just quickly check, translate. There it is there. We have a point and a translation amount, so an amount that we need to add onto the x and y coordinates. We read off the x and y coordinates, read off the change in coordinates, and then just add it together. So when we put in a negative number, yeah, great, we get it. So we're subtracting the camera's position, and then we are adding on 150 to each. So to each of x and y. So what that's doing is, I'll just run this. Okay. So at the moment, look at the blue wall. The blue wall is 150 pixels to the right of the camera. So what this code does is it subtracts the camera's position. So that sets it to, 0. Oh, sorry, sets it to 150. Because it's 300 basically, minus 150, and then add on 150, so set it back. But as the camera moves towards the wall might only be like 50 pixels to the right. So subtract the camera's position. That gets it to, 50. And then add on 150, so 50 plus 150 is 200, which is why it's drawn, a little bit off. But yeah, okay, so a lot of talking for not much result. What we're doing at the moment is we're moving the world around the camera. So at each step, subtract the camera's position and then add the position of the center of the screen. And that will result is this. Anyway, that's more than enough for now. What can we do as exercises? Well, I'll chuck the code up in the video description and play around with it. So at the moment, well, first of all, just take this as an opportunity to go and read the code, read up on Pygame and get comfortable with it. But see over here, I'm just kind of typing all this data in by hand. Good extension for this would be to write it into a text file or something and read it in just using Python's file functions. Automate this process, make it a little easier. And then try to find a way so that the movement is frame independent. So we don't have to cap this at 60, we can have it running at, you know, hundreds of frames per second and it's not janky. Okay, that's it. Have fun. And yeah, signing off.